In today's video, you're going to learn how to use the spectrophotometer and its results to determine the concentration of several solutions as well as an unknown. Let's get started. Before using a spectrophotometer, a set of dilutions with gradually decreasing concentrations should be made, as well as a sample of your unknown and a blank solution. Once you've completed this, obtain cuvettes and carefully transfer each solution into its designated cuvette. When filling the cuvettes, make sure that you get as close to the marked line as possible. In these clips, you can see examples of us carefully filling the cuvettes with the various solutions. Once your cuvettes have been filled, you're ready to go to the spectrophotometer room. Make sure to carefully clean two sides of the cuvette with a chem wipe. When placing the cuvette into the spectrophotometer, position the clean sides so that the light will be passing through to ensure a clean reading. The first solution you'll be placing in the spectrophotometer should be the blank. You should start by zeroing the spectrophotometer in the program called Scan. Once this has been done, you will scan all of the solutions across all wavelengths. Why should you scan across all wavelengths? You should scan across all wavelengths to identify which specific wavelength you will use to determine the relationship between the absorbance and the concentration. By doing this, you're able to gather which light wavelength is the best for determining the absorbency of the solutions. The specific wavelength that you find will also be the lambda max. The lambda max is the point of the maximum absorbance at the wavelength. As you see in this clip, our lambda max was at about 560. After using Scan to identify which wavelength to scan the solutions at, you should proceed to simple reads and adjust the settings of the wavelength to be about 560. Next, find the absorbances of all the solutions. As you're scanning all of your solutions at the specific lambda max, be sure to record all of the absorbances that you get from the spectrophotometer into your notebook. This is an example of what your notebook should look like. In order to find the concentration of your solutions, the equation M1 times V1 equals M2 times V2 can be used, but for this lab, you should use Beer-Lambert's law. Beer-Lambert's law can be written as A equals epsilon times C times L. A represents the absorbance, epsilon represents the molar absorption, C is the molar concentration, and L is the optical path length. In our case, this will always be 1 centimeter. Since Beer-Lambert's law describes the linear one-to-one relationship between absorbance and concentration, you can determine the absorbance of a solution. To find the molar concentration, you can manipulate Beer-Lambert's equation to look like C equals A divided by epsilon. L will always be equal to 1, so you do not have to include it in your work. Once you're done with the spectrophotometer, make sure that your area is picked up and clean. Thanks for watching.